Okay, I think let's start. Everybody from the service has run away. Let me just start the timer so I know how late I am. Hello everybody, my name is Łukasz and I would like to tell you today about our story of migration from Mesos to Marathon and Marathon to Kubernetes and some tricks that we have done to make it happen and problems we faced. To have some kind of a background, let's get some general boring facts about what Holiday Check actually is. We are one of the biggest travel websites in DACH market, that is Germany, Switzerland and Austria. We have over 30 million of unique visitors per month and many bookings done on our website. What I am doing in this company, I'm a big panda, which is a coaching leader of team of ops consultants that consult products, teams and developers. Yes, this used to be my desk. Now I have much smaller. I'm also a people and practice manager to some developers, and I'm a former member of Team Dust, team that designed our first microservice cluster and is still maintaining it and also designed the whole migration process. And fun tech facts. We have two microservice clusters on production right now, obviously Mesos+Marathon and Kubernetes. Most of our infrastructure consists of microservices that are run inside Dockers. So we have around 280 images live. Some of them are upscaled, so it results with over 700 instances or pods in the production environment. These services are developed by 13 product teams in 3 locations, in Poznań, in Munich, and in Switzerland, in Botighofen. And before that presentation, I have checked our deployment log, and the average rate of deployment is 8.5 per hour. So we deploy new code to production every 7.5 minutes. About a year ago, I have held a talk about lessons learned after 2 years with Mesos+Marathon and Docker. And the outcome was that we should move to Kubernetes. The main reasons were community, that Kubernetes has much bigger community. It's much more stable. It's actually designed for the purpose of microservices, whereas Mesos and Marathon has feels like different services written for different purposes, and they were tied together with a duct tape. And that's how we felt. Also, we wanted to have some features that Mesos did not provide, like isolated namespace or proper user access control, or just to have a zookeeper that doesn't blow every month. So yeah, we decided to go for migration. But how we do that? First of all, we have come with a list of requirements. There were 4 core requirements. For the starters, we wanted to have a zero downtime. So we need to make a move of the microservice without any effect on the users that visit our website. The second is the minimal work from developers' side. In our company, developers have much autonomy. So even deployment pipelines are managed by development teams. Of course, ops are assisting. Nevertheless, we need to ask developers to change the deployment pipelines so it's deployed to a different cluster. And we didn't want them to change the code of the application anyhow. Third requirement, quick switch between clusters. So if anything goes wrong when we switch from Mesos to Kubernetes, we would like to have the ability to go back very fast. And in the end, support for cross-cluster dependencies. So if we have a service A depending on service B, we wanted to have the ability to move the services independently so we don't have to do it in batches. And we could do it simply, easily, one by one. So that took us to part 1, setting up the cluster. As our infrastructure was mainly in Google Cloud, we decided to go with the Kubernetes in Google Cloud and especially the hosted version. Just out of pure, that we are lazy. We didn't want to have a maintenance over the masters of Kubernetes, so we decided to go for that. However, we wanted to tune it a little bit. We decided to keep all the configuration in YAML files in our GitHub repository, so they are versions stored, and we wanted to do all changes by API, not by web UI. What's more, load balancer. We decided to go for a load balancer named Traffic. Traffic is a seemingly young project. It is about 2 years old, and it has very nice features. It's written perfectly for microservices, and we wanted to use it, not the default Google Load Balancer that was offered to us, because Traffic allows us to do much more customization. And what's more, the cool feature that Traffic has, that it could have multiple microservice clusters as backend providers. In Traffic, they are called providers. So we had Traffic in the front, and Kubernetes and Mesos in the back. So Traffic was the single point of distributing the requests. However, to make it funny, we wanted to have the load balancer for the microservice cluster deployed inside microservice cluster. Why? Why not VMs? Because we wanted to maintain it easily. If we want to upscale it, we just need to do the upscale. If anything fails on single node, the scheduler, the orchestrator should take care of it. So we have come up with a solution that we created. We did it by creating a separate namespace for Traffic and also creating another node pool for Traffic. And we have written a dedicated Kubernetes controller called Dust Node Controller. And its purpose was to ensure that Traffic can be deployed only on very particular nodes, Kubernetes nodes, and no others. And any other service could not be deployed on these nodes, just for the safety reasons, not to be affected by performance of other services. And we also decided to stay with the tooling we have prepared for the Mesos cluster for our developers. We called it Deploymate. And Deployment is a simple microservice that was easing the deployment process for Marathon. It was offering developers a simple REST API that you could call, and it was taking care of deploying to Marathon, which was not that difficult, but it was also setting up the load balancer. What's more, we could then apply some default labels to the deployment for debugging purposes. And on top of that, we offered also a DMC, which is Deploymate Client, a simple CLI that can be called. And developer, instead of posting a complicated JSON or any other stuff, could simply execute DMC, giving two minimal required parameters. One was the deployment path, and the other one was the Docker image. So it was that easy. And this tooling proved itself when we were migrating the Mesos cluster from our dedicated co-located data center somewhere in Germany to Google Cloud, because it allowed developers to just switch one target of deployment, to switch cluster parameter from production TOS to production GCE. This is how it works. I already explained. We have user, we have DMC that can be called to Deploymate, and based on the cluster parameter, proper cluster is selected for actual deployment. We also wanted to do it right this time. This was the second cluster we have come up with. Obviously, Mesos was lacking user authentication control, and we read that there is a role-based access control for Kubernetes. Unfortunately, at that time, it was in alpha state, so we needed to wait a bit. But in the meantime, we had a closer look at the feature set. So in Mesos cluster, we used HA proxy combined with a small tool written in Golang that was called Bamboo. And the name was very unfortunate because you always have to call it Bamboo, but not the Atlassian one. And it appeared that Traffic was missing some significant and obvious features, like configurable health checks. Traffic had them encoded, and our developers were given the liberty to call the health check endpoint anyhow they wanted. So we needed to do that, or cope with it somehow. It was missing readiness checks that we introduced in the Bamboo and HA proxy. So the service that was already considered by orchestrator healthy could be also considered if it's ready to actually serve traffic, because it could as well need to set up connection to database or warm up its cache. Traffic was also providing some Prometheus metrics, because Prometheus is the monitoring tool we use for our infrastructure. And nevertheless, the metrics were very, very simple. and so we needed a more detailed one to actually keep a close eye on our infrastructure. What's funny that Traffic was also missing a basic feature that is timeouts. So there was no timeout at all. Simply, if you call a service that is stalling, you could wait a year or two, and nothing will be cut. So this comparison made us think whether we should take another approach to another load balancer or maybe stick with it. But we decided to invest some time and involve in the development of the upstream project. So we got involved. Two of our friends were so PR submitting, so they have become official traffic maintainers. And in general, we got about 50 pull requests merged upstream in the traffic project. Cool. Everything was covered. We have implemented all the features. In the meantime, role-based access control was actually released. Now it was time for first testing. So next to this first Kubernetes cluster, we have spin off the simple experimental Mesos cluster, an empty one, to play with, and we deployed the first service. And with the first service, we had a first problem. It appeared that when you have two backend providers, like Mesos and Kubernetes, and you deploy the same application under the same path on every of them, traffic decides to route the requests in a semi-random way. It can be understood, it can have its reasons, but we couldn't accept that because we wanted users to first deploy application to Kubernetes, test it, and then decide whether the traffic should be handled by this application or not. So one of the pull requests of the 50 ones we have introduced was also to sit down and implement something called cluster priority. So introduced a config flag that was both global and per service overridden, that decided which cluster will be taking care of particular path when you deploy it. And by default, our setting was it's Mesos. Unless you switch it manually or in any other way in config to Kubernetes. And then this particular path was having the requests redirected to Kubernetes. Cool. It was done. The service was ready. So we started thinking, what about performance? We have never tested that. So we started doing some benchmark of traffic, and we were pretty disappointed because it appeared that in our setup, one traffic instance was able to handle like 800 requests per second. This is not enough for our purpose, but let's compare it to Kubernetes. So we decided to compare latency. We compared the 99th percentile, which is the worst 1% of all requests that we have probed. And for HA proxy, you have 10 milliseconds of latency, whereas for traffic, you have 25. Well, the difference is big. But if you think that HA proxy represents, I'm not sure, 16 years of fine-tuned C project, whereas you have traffic written not that long ago in a garbage collecting way language, that's the explanation. So we needed to involve in the traffic even more and tune it a little bit. And we did some optimizations with debug logging, with some mutex exceptions. And we also helped to drive pull requests that was not originally ours, but we insisted on having it merged upstream. And it gave a really huge boost to the performance. By default, traffic was comparing paths of the front end, so to match to the proper backend to send the request to, with a regular expression. The pull request I mentioned was about to change it to only prefix matching. So it started from the left side and was comparing streams from the left to right to match first occurrence. And it gave a huge boost. And along with all other optimizations we did, we finally managed to increase the performance of from 800 to 3,000 requests per second. To be honest, in total, all the work involved with the open source project costed us about a quarter of teamwork. But in the end, it was worth it. Because now we have a nice bond with the community, and if we need additional features, we can have them merged faster, because we already earned their trust. So once we had it solved, we decided that we discard the Mesos cluster, the testing one, and yeah, let's connect the actual production Mesos cluster to the to our traffic inside the Kubernetes to see if it recognizes production services properly and see what's happening. And after we did it, we experienced another problem. We had errors in logs. These errors were strange, connected with timeouts. What's more, these were DNS timeouts related to health checks. So traffic was trying to send health check requests to the services in Mesos, and we had like 10-15% of requests getting timeouts. So we started investigating. We did it for about 2 weeks, whole team time. Afterwards, we contacted Google first line of support, and when we were almost tired and fed up with, you know how the first line of support in Google is. You call them, you explain the problem from the beginning, and they apply to you the procedure that they normally do. But after 2 weeks, we finally got the second line of support, which was the actual engineer. So we had like 15 minutes hangouts, then the guy was testing something and getting back to us. And after another week, we finally found 2 root causes of the problem. First one was called ndots. Ndots is a parameter for the DNS resolver that can help the resolver identify whether the hostname is fully qualified, considered fully qualified or not. By default, the ndots has a value I've seen 1 or 2, so you can have the google.com as a fully qualified domain with 1 dot or www.google.com. Our Mesos setup was, our Mesos slaves had host names instead of IPs. And you know how it is on Mesos. If you don't know, then the containers running on Mesos slaves are exposed on random ports. So you always have the Mesos slave hostname on it. And our setup, as shown here, had 3 dots. For some strange reason, the DNS resolver for the internal DNS resolver in Kubernetes has hard-coded value of ndots5. That means this hostname was not considered as fully qualified, and the resolver tried to concatenate it with some search domains it had stored inside the Google. And it appears that Google has lots of domains. It resulted in thousands and tens of thousands requests. Okay, but DNS is a pretty performant protocol. It's running over UDP, so I could understand a slowdown, but timeouts? And this was another, this was connected to another finding. It's, at the time, it was half a year ago, it was not documented at all. Maybe it is documented right now, but internal DNS servers in Google have a guard service that is standing right in front of them, and it ensures that you don't have more than 32 concurrent connections from your node. So, as an example, if you want to resolve some domain name, you send a DNS UDP packet, it's stateless. Let's say in the meantime you need another one being resolved, but before you get it, the number 1 should already get back to you with the response. Nice, but what if we have sent out so many requests that we have populated all the slots? What if we have sent out even more requests, so we started overriding the slots before we get the response? It's a UDP protocol, so you don't know you don't have the information about session, so you don't know if the response was set on that. And this is simply what happened. When we overloaded the guard service, the request sent previously to slot number 1 was overridden by the new one, and the previous one was considered dropped, hence the timeout. How this can be solved? There are several solutions to it. You can add dot in the end of the hostname, so you force it to be considered a fully qualified. You can write your own resolver, it's a sidecar solution, and add it to the config map. But in the end, we decided to do a temporary patch on traffic, so we forked the project, and we are translating host names to IPs upon config load. We have constant number of Mesos slaves, and we are rather decreasing them than increasing. So the single translation them to IPs, it's much easier for us. And it's also a temporary solution, because once we get rid of the Mesos cluster, we can get rid of this special setting, because in Kubernetes you have everything identified as IP addresses. Cool. So having the performance checked, having the actual production clusters connected, we needed to figure out how to quickly recover and upgrade our cluster. We decided to write our own tool. Why? Because in general, we had our configuration written in several YAML files, and it appears that Kubernetes API is not that perfect. So you needed to call different API endpoints with different YAML files, and you could possibly forget some of them. We wanted to have one big YAML file for the whole cluster definition, and then apply it. We have written a tool internal called Poseidon, and this tool was parsing the one big YAML file, dividing it into proper chunks, and calling respective API endpoints. What's more, it was supporting easier compute pool upgrade when you need to upgrade Kubernetes nodes. So I will tell about it in a second. And for data recovery, we have used Heptio-Arc tool. I don't have many information about it. I just know we use it. And it's used for periodical backups, and it can be called by Prometheus automatically to recover recent state of the cluster. About the upgrade. So if you have a hosted version of Kubernetes and you want to upgrade the compute pool, so the nodes that are actually carrying microservices or pods, let's assume that you have a 3-node cluster. First, what Google does, it's like a rolling upgrade. So first node is selected for upgrade, then microservices are drained from it, then the cluster, while empty, is being upgraded, and the second node is being selected for upgrade, again draining nodes, again upgrading, and the same with the third one. It's okay, but it takes time. It's very time consuming. For once, if it goes bad in the middle of the process, the recovery, the rollback is done in the same way, so it also takes time. And the microservices are being pushed around the cluster all the time. What we have came up with the Prometheus tool is that having the same cluster, Prometheus tells Google to create another compute pool with already upgraded Kubernetes nodes, and the services are migrated once. If everything is ready, the old compute pool is being discarded. It's much faster, although, to be honest, it's much more resource and money consuming, because you simply need to duplicate the cluster for the purpose of upgrade, but it's a short-term one. Great. We had a cluster. It was performant. It was tested, running, and somewhere in the beginning of the year, we said, "Hey, we are ready. Let's deploy." And some developers were, "Yeah, good. How we do it?" And okay, let's use just deploy-mate because you know how to use it. Just deploy to Kubernetes. Fine, but how do we actually test if our services are running or not, how they behave? So we started educating people. We did some workshops, and people are very, very interested on the workshops. They were asking questions. There were some trainings on hands-on labs. But after a week of going back to their everyday tasks, they forgot everything. They forgot how to use Kube dashboard, because it is overcomplicated. It allows you to change almost every setting of Kubernetes, and developers that don't use it on a daily basis, they don't need that. So we decided to build our own dashboard. We called it Centrale, because, well, Holiday Check is a German company, so at least some of the services have to sound German. That's why Centrale. And it's a very simple dashboard that lists the services, allows basic control over the services so developers can interact with them and don't have to switch tabs to find their area of interest. And it also helps with Mesos to Kubernetes move, which I will show in a second. This is a screen of Centrale. It has a search filter. It has a list of services. You have information about how many containers are deployed, how many pod replications done. You can access stack driver logs quickly. You can access Grafana metrics from Prometheus, and you have a basic control over the pod of the service. You can also upscale or downscale it. But if you have the same deployment, so the same service deployed in the same path on Mesos and Kubernetes, here on the very right side, you will have a special button called Activate Kubernetes or Activate Marathon. And when you click it, then automatically traffic will be told to change the priority of the clusters. This is what I told before. So this is the place when you deploy to one and the other cluster. If you want to, hey, let's start using Kubernetes for our web page, I don't know, hotel index page. So you click the button, and in a second, the whole request flow is redirected to Kubernetes. If you get a higher error rate, you click the same button because the label changes to Activate Marathon, and you go back to the safe state. And yeah, people liked it. People liked it very, very much. What's more, we had a button to actually roll back the state of the service to some previous revision in a similar way that it was done in the Marathon. So you can click on any service rollback to, and you have information about the current revision. You can check details like Docker version or Docker image name with tags, and you can apply with a single button how to you can apply the current configuration so the redeployment is being made. It's very useful, especially for the on-call people who don't know what changes in the code were done, but we try to follow deployment manner that we deploy things that are not breaking changes unless we explicitly announce it. So it's safe to apply a previous version instead of fighting fires all the night. Yeah, so first of all, developers did some minor services with the migration, and we faced the first major move. It was our forum application. Very resource consuming, very popular. And we have some problems. The forum guys approached us and said, hey, good job with the migration tooling. It is very clear, we can understand it, great. There's just one problem. We noticed a slowdown. So we asked, okay, but how big is the slowdown? Around 30%. Oh, that's not good. So we started debugging, and we found out that it was caused by CPU throttling. We made kind of a mistake, or we didn't pay attention to it at the very first phase when we were designing this cluster, that there was a parameter called CPU quota. Well, we had similar CPU parameter in Marathon, and no matter what you actually set there, it didn't bring any difference to us. So back then, when we started designing Kubernetes, we said, let's give it like 1.5 CPU, should be fine. There are differences. In Marathon, the CPU setting is like a weight, a priority. So if you have Marathon running on a system like Ubuntu, which has a smart scheduler to the CPU, this smart scheduler can take these priorities you set, because all of them by default are 0.1. It can take them into consideration and assign the higher priority containers first to the CPU. Whereas Kubernetes has a hard CPU limit. So if you have a container with 1.5 CPU, you actually get the computing power of 1.5 CPU machine. And Forum was hungry for more. So right now we did some testing, and we have set, as for now, we have set the global setting for like 3 CPU, and we are fine, but this is still something that should be tuned. Nevertheless, I got a message from my teammate about this CPU, that right now in the Kubernetes community, there's going on a discussion about the CPU quota, because many people would like to have this parameter thrown away, removed, just because of the features that you can unintentionally set it wrong and experience problems. Our representative from Holiday Check tries to convince people that although it is dangerous, it also saves you from some services that are very hungry for resources, and we would like it to we would like to have it kept and not removed. We experienced such a problems before when we had a Mesos slave with like 40 or 50 Docker containers in it, and there was one greedy service, for example, CEO service that was regenerating the whole sitemap, and it was it was having so big hunger for the computing power, so it simply killed the whole slave. With this CPU quota, it would not happen. So one takeaway is that we should really observe what's going on in the community. State of now. As for now, we have 30% of services moved, plus minus 2% right now. The move of the service can be done in 15 minutes. So it concerns changing the deployment pipeline, performing one deploy, testing Kubernetes like separately, switching traffic, testing again. So it's not more than 15 minutes. However, we still need to push people to do the move. Why? Because we fell victims of our own decisions. We wanted to create our microservice infrastructure as Dust team in a way so developers don't have to interact with it much. So it's transparent to them. And yeah, and these were the responses we got. So we approached them and say, hey, we have this Kubernetes cluster, please do the migration, it will be fun. You will have a new cluster. And we got a response like, okay, but why? I'm doing this the same as before and the same I will do later. I deploy my service with deploymate. I check my logs with Stackdriver. I ask the proxy or default Nginx to test the service. I don't see any difference. So there's no difference for me. So sometimes we have to use some blackmail, like, oh, you're having logging problems. Yeah, let me help you, but if you migrate to Kubernetes, it will be much easier to help you. Yeah. So hopefully, with all these tactics, we will have our Mesos cluster destroyed by the end of the month, August. And so some key takeaways. Let me just take a sip. So, in all, we consider move to Kubernetes a good decision. However, Kubernetes is way more flexible, but also more demanding. So the flexibility gives you have the ability to change every parameter of Kubernetes, and that's a plus. The disadvantage is that you have to set every parameter. And second, if you want a non-trained users, like developers that don't interact with it on a daily basis, to touch Kubernetes, it's a good idea to build a dedicated dashboard, so to make it easy for them. And as we said with the CPU quota discussion, the project is developing rapidly, and we need really to keep an eye on it. So we don't have the surprise that feature we really are using, it's suddenly announced as to be deprecated. And having all the problems and tunings and upgrades, you really need a dedicated team to look after this cluster. It doesn't have to be a big team. So far, Team Dust has, after I left, there are 4 people. One of them is half-time working for them. And it's enough. Nevertheless, you should have a dedicated team, and we have it aside from ops engineering team and other platform teams. Yeah, and that would be all. Now we have time for some questions. No questions. And thank you.